Hi all, part 3 is about the last couple of functions regarding maths for electricians using the Casio FX85 GT. The input values for sine and cosine into a calculation are, as you will see in the next slides, straightforward. Also, I thought it would be useful to revisit a couple of topics from our school days. Let's crack on. So, we can find the sine or cosine of an angle as shown. We then convert the answer from scientific notation to decimal. So the cosine of a 30-degree angle is 0.866. Next, we obtain the sine of a 90-degree angle. In this instance, the answer is 1. If we have a sine or cosine value of an angle, we can then convert it into an angle by using the shift key and using the same functions as shown. As you can see, the input of sine and cosine into a calculation is quite simple. Let's now look into the properties of a right angle triangle, as this will have a bearing on calculating power factor, voltage drop in cables greater than 16 mil squared, three-phase, harmonics, and more. So, right-angled triangles. Although the use of the Casio calculator makes life so much easier, it's worth looking at how and why Pythagoras and geometry have relevance in electrical design and various calculations found in BS 7671. Firstly, let's revisit Pythagoras. If we identify side C as the hypotenuse is always the side opposite the right angle, we can work out the length by the formula shown. C squared equals A squared plus B squared. So in this example, 30 squared, which is 900, plus 40 squared, which is 1600, equals 2500, the square root of which is 50. By transposition of this formula, so long as we know the length of any two sides, we can calculate the other. Transposition will be the subject of a later video. Once we know the length of the sides, we can employ geometry to work out the angles of a triangle. This is where sine and cosine are used. At the beginning of the video, we saw how to convert angles into either sine or cosine into a numerical value and back into an angle. These slides give a view on how it's represented on the Casio. The hypotenuse, as we previously stated, is always opposite the right angle of 90 degrees. The opposite side is always opposite the angle we are trying to determine, and the adjacent is the remaining side. In this instance, we know all the side lengths, so both sine and cosine give the angle of 37 degrees. The same goes for the remaining angle, but notice that the opposite and adjacent sides have changed. The impedance triangle is just one example where sine and cosine are employed, and I intend to produce more videos in further applications, including three-phase. Please comment and give feedback on any particular aspect you would like to be covered. And if you found this of interest, don't forget to like and subscribe. Thank you.